right, so again, everybody needs to go to the main Schoology page, which, by the way, if you've not written down your assignment, I told you yesterday to shift to 1 to today, because we did not get to it yesterday. In Schoology, which of course it logged me out. So you want to go to our main page, the updates, not materials, but the updates page. Make sure that your computer is muted. Bless you. Bless you. So we are going to try something new. Well, I'm trying something new this year that you guys are going to take part in. And the feedback that I've gotten so far is that people like it. They think it's pretty cool. So this new thing is called an Ed Puzzle. And what an Ed Puzzle is it essentially takes that recorded lesson and lets me break it down into segments that then have related questions. So on your computer, with it muted, go ahead and click on this little video box, and it's going to ask you, hey, wait, you need to make an account. Now, being on a Chromebook, you should be able to make an account straight with your Google info. So tell it that you are a student, which it should be selected automatically, and then click Login with Google. Yeah, then it should ask you to join Accelerated 7. Then you can go ahead and let it play if you want. We're going to watch it all together, but to get an idea of what's going to happen, you can go ahead and let it play. Is anyone having any issues with this? No, you don't need headphones. We're going to do this all together. We're going to watch this as a group. So this was last night on the way to the field hockey game. And actually, there's not really any audio because I was just sitting in my car. So check it out. We start assignment, and I can full screen this if I want to, which I always do because full screening is way better. So check it out. I start the video, right? I'm stuck by a train again. So the first question I ask you is, right as the red train car passes the telephone pole. So a red train car, kapow, is going to pass the telephone pole. What is the timestamp? Which a timestamp is how far into the video are we? Don?
2 seconds.
2 seconds, right? Right down here at the bottom of your screen, you can see 2 seconds. So you would click 2. Now, some of you, if you want, because this is not for an actual grade, you can get answers wrong. So if you choose to, get it, but I warn you, watch what happens if you get it wrong. Somebody get it wrong and tell me what happens. It just shows up red. What option do you then have? You could re-watch it right here, or you could try again. So I can then submit my answer, and then it will let me continue on playing the video. I cannot skip through this video. I cannot speed it up. I cannot change anything. I just have to watch it at its own pace. Now, how many train cars have passed by, starting with that red car? Did you count them?
No.
So, if you didn't count them, eyes up here. Eyes up here. I didn't count these. I didn't know what question was coming. Rewatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's going to be car 10. So, 10 cars passed by.
There's no try again. There's a red semi. Oh no.
Does it let you move on though?
Mine says so
So if you rewatch it, does it then let you do it? So that might be in my settings, which is okay.
Mine is glitching out really bad.
Oh, it's telling you the right answer. So, and that, hold up, this is probably in your settings. Don is letting me know that he got it wrong on purpose. And then when he rewatched it, it still told him his wrong answer, but then it tells him the right answer that you should have had. So, like, if this was happening through a lesson, like if we had flipped class and you were doing the lesson for homework, you'd want to know what the right answer is. You wouldn't want to struggle forever. So, I think that's in my settings that I can adjust whether it's going to give you the right answer automatically or make you try again. So, we got 10 cars, right? I continue, and, like, immediately there's another question. Or, sorry, I just... what the heck?
This one is crazy.
This just missed.
It does that.
Hold on, mine's goofed up now. I think because of the smart board.
It was called happened I have no idea.
Did it ask you how many seconds had elapsed?
No, it was the unit rate for train and cars.
So hold up, continue. Yeah, there we go. How much time has passed? Oh, that should have been since. Sorry. Since that timestamp I asked you about. So how many seconds are we at now? 12. Yeah, so how much time has passed? Yeah, so be careful. You might want to say 12 because we're at 12 seconds, but it's not. Only 10 seconds has passed by. So only 10. Submit, continue.
But I don't get this.
Now this was really funny because this truck happened at just the right time. So I was like, okay, great time to stop and put a question. What was the unit rate for the train in cars per second? Whitney, you want to process through that?
I just said 1 car per second.
How'd you get that?
Because as they were going by, after each one go by, it was like 1 second.
Yeah. We saw 10 cars go by in an elapsed time of 10 seconds. So I do that division and get that it's just 1 car per second. And then I continue on. So, the final question then, if I were to sit here and watch this train go by for 3 minutes, how many train cars would I count? So, obviously, all of them is just a goofy answer. Solomon, what are you saying?
1 times 60 times 30, then you'll get your answer.
So, 1 car per second times 60 seconds in a minute times 3 minutes in this problem. What do you get, Solomon?
No idea.
180. And then we finish up the video, and that's the end. And the train stops right as my phone actually ran out of data. So I got to wipe some things on my phone. But that is an Ed puzzle. So then, check this out. Give me your eyeballs. So I can then go to Edpuzzle, and I can check out all of the data in real time. So you guys just watched this. I can check out. So Flynn is still, or like hasn't finished watching it yet. Ozzy through Dominic, they got a 60% because they got some of their questions wrong. So especially because I know Dom was doing this on purpose, I can then go to Dom and see, okay, how many times did he watch each section of video? How many times did he, or like what did he answer for the question, and what should it have been? So I can see all of these analytics for you guys. So what tells me when you watched a section 5 times was you either really liked that section or you were really like struggling with what was going on. Like maybe you thought it was funny and you were replaying it for somebody, or maybe you were struggling with that question. So this is an awesome teaching tool that we are going to start using more and more this year. I have another one posted. I don't know if I posted it on yours. I'm working on a new one about my curb leaking. And I have another one posted about a music video. So I'll post the music video one on your updates page too. But that's just like an optional. You can do it for fun. If I go back to my made Ed puzzle page, it is, right now I did it with Math 7 yesterday, but it's, if you've ever heard the song Stereo Hearts, which you probably don't know the title, but you probably know the song. So all of that, just to introduce what Ed puzzle is. So in proportional relationships, here is our learning target. So you can log off, shut those, stick them under your desk. We will put them back at the end of class so that we do not bother Mrs. Goldring's class.
What would be cool if, like, you could, like, stream the videos? So you could see it.
Yeah, but I couldn't like make the questions live. Like that would be tough.
No, but, like, with our class video.
Oh, I could stream that live if I wanted to, but I don't think anyone would really watch it live. Even people that are sick.
I tried to watch it when I was gone. I was, like, trying to.
Yeah.
I was like,
All right, so Evie, please put it away. Solomon, put it away. I can see by your smile you're definitely not following my directions. Yeah, you're not. Should we talk after class?
No.
Okay, figure it out. Everyone have your 2-1 notes? So the first thing we talk about was proportional relationships. I'm sorry that it was the worst thing ever. Can we move on to math so I can make your life better? It's okay. So, proportional relationships. I have a table up here showing an example. if no dogs are injured, I have to put that out there because every year people are like, but what about? Because, I mean, if you haven't seen a three-legged dog, it's pretty impressive. My dog, Sebastian, got hit by a car, and for a while he had his one leg taped up to reset in the socket. Dogs can operate on 3 legs perfectly fine. It's pretty amazing. So, if we had 2 dogs, we would expect that there would be 8 paws. If we had 4 dogs, we would expect there'd be 16. If we had 6, we would expect there to be 24. How do we know that? How can we figure that out? Sam?
If you find the simplest ratio, then you can just create
What's the simplest ratio for a dog?
one dog equals 4 paws.
1 dog has 4 paws. What would that be? Things that we talked about last chapter. If there are 4 paws for 1 dog, it is a ratio, but more specifically, Noah? It's a unit rate since it's per 1 of something. So, we know our unit rate is 4 paws per 1 dog. But what if I had no dogs? Then I'd have no paws. So, proportional relationships are just... Who passed out the 2 OneNotes? Where are the extras? Andrew, did you give one to Solomon? Or did you give us the extras? Huh? There you go. No? Still no extra? Come here, Saul.
Oh, right there.
Oh, you put it on an empty desk. Our invisible student is not here today. So, here's what makes up a proportional relationship. A relationship between one quantity to the next that is a direct multiplication. So 4 paws per dog, we can multiply by 4. If I wanted to talk about eyeballs and relate that to students, I always say, give me your eyeballs. How many eyeballs should each student have? 2. So we can make a graph or a table relating eyeballs and people. And it would always be, the eyeballs would always be 2 times the amount of people. If there were no people, there would be no eyeballs. So, X and Y have a proportional relationship if Y is always a multiple of X. This is a term known as direct variation, which I believe they like to use on those state tests. So you need to realize proportional relationship and direct variation mean the same thing. They're essentially synonyms. Direct variation is a proportional relationship. Because when one item varies directly to the other, that makes a proportional relationship. So, if we're looking at side length and perimeter, if we talk about a square, what do we know about a square? Jeremiah?
It has 4 equal sides.
4 sides that are all equal to each other. So, if I have side lengths of 1, I have a perimeter of 4, and my ratio of perimeter to side length, we need to fill that in. Well, my perimeter is 4, and my side length is 1. So we set up the ratio of 4 to 1, or 4 over 1. And that would reduce out to 4, which is fine, because it's already essentially 4. It's just in fraction form. If I had an edge length of 2 on my square, Jeremiah? 8. And then we set up the ratio of 8 to 2, and that also would reduce down to 4. Just use this. Yep. What if we had an edge length of 3, Ellie? Perimeter would be 12. I agree. What were you about to say?
I was just going to say because I see a pattern. 4, 8, 12, 16.
Yeah, really what our pattern is we're multiplying by 4 to go from side length to perimeter. So now when we fill this in, it's going to be 12 to 3, which also reduces to 4, or 4 to 1. Jaslyn, what about if we had a perimeter of 16? Yeah, we'd have a side length of 4. 16 to 4 still comes out to be 4, or 4 to 1. What if we had an edge length of 5, Jeremiah Smith? If you had a square, edge length of 5, what's your perimeter? 20. And that's 20 to 5, which reduces down to 4. And an edge length, or sorry, a perimeter of 24. Noah, what's our edge length then? 6. We get 24 over 6, and we get 4, or 4 to 1. So, does the table above show a proportional relationship? Why or why not? Monica?
Yes.
Why?
Because 4, the perimeter is.
I'm actually going to put my because up here right beside the table, so if you want to do the same, you could. So perimeter
Is a multiple of the side line.
Yeah, so it's what multiple?
It's always 4 times.
Is always 4 times the side length. So because our perimeter is always 4 times the side length, that makes this a proportional relationship. And what if I had an edge length of 0? What would my perimeter be? 0. Is 0 4 times 0? Yeah, because it can be anything times 0. Jeremiah?
So proportional relationship just means it like repeats equally or correctly?
If you mean it like adds the same amount each time, if that's what you mean, then yeah, because that's what multiplication does. It continues to add the same thing over and over and over again. So we're multiplying by 4 if I look side length to perimeter if I go this direction. But if I go this direction, I'm adding 1 to each side length or adding 4 to each perimeter. So if we think about area now, same problem, still thinking about squares, but how do we find the area of a square? Which if you have space, I'll change color. It'll bounce around the edges too. How do you find the area? Area of a square. Jeremiah? But what do we know about the width and the height? Or the width and the length or whatever? They're all the same. So we really just say that it's the side length squared. Because it's the side length times itself. So if my side length was 1, my area would be 1. Let's just go through the top here and fill all this out, and then we'll kind of fill it out going across. So Whitney, if you were to make a guess about what would go in these boxes, when I have 1, 2, 3, blank, 5, blank. 4, 5, 6. Now let's check it. If I did 4 times 4, would that be 16?
Yes.
Yeah. If I did 6 times 6, would that be 36?
Yes.
Yes. So now let's go back and deal with our areas. Ozzy, if I have an edge length of 2 and I square that, what do I get? 4. If I have an edge length of 3, Manasa, and I square that, 3 times 3 is? 9. If I have an edge length of 5, Elena, 5 squared, or 5 times 5 is? 25. So now fill out your ratios and answer the question of does that table show a proportional relationship and explain why. You have to have an explanation to why. You guys use the top shelf because I know that I can just keep stuff off the top shelf. Try not to look at the board.
Should we solve the ratio of area to side length?
Yeah. That's you want to fill in all of these and then answer, is it proportional? We only have area inside that. Now, so if you're going to replace it with area, you see that area is always the same as the side length. So it's not. Side length was 2, area was 4. Side length was 3, area was 9. Side length was 4, area was 16. You might be talking about this ratio. But if that's squared, is there a consistent multiplication? So, in the first one that's still up on the TV, we said that we have a proportional relationship because I can take my side length, multiply by 4 always, and get the perimeter. Because it's a square. That's how it works. So what do you think about this table involving area? Is this a proportional relationship? Anish, what do you think? But we're not talking about perimeter. We're talking about area. Okay, so we did times 2 here. If we're trying to do the same thing as before. Can we do times 2 here? Ah, this is not proportional. It is not. Because the reason that table was I could multiply by 4 every time to go from edge length to perimeter. Is there a consistent multiplication here?
No, but you're squaring it by. Well, yeah.
That's not a consistent multiplication, though. So, yeah, because this is times 2, times 3, times 4, times 5, times 6. My multiplication's constantly changing, so it's not proportional. And here is a visual of what it would actually look like if we graph it. A graph of a proportional relationship. If you ever want to play with math, Desmos is one of my favorite math websites to play on. I'm serious. Beautiful free math. So a proportional relationship. We said the perimeter was 4 times. So I'm going to say the perimeter, or actually I have to use y and x. We'll make y our perimeter is 4 times the x value was our side length. So if our side length was 1, perimeter would be 4. If our side length was 2, perimeter would be 8. Kind of see how this graph is working? Yeah, it'll go on forever. So if I talk about the area, now y will be my area, but that's the edge length squared. See how it does not look proportional? It does not go up consistently. It's getting steeper and steeper and steeper, because if I zoom in right here, it's actually called a parabola. This steepness is not that steep. If I zoom in up here, look at how ridiculously steep it's gotten. And if I keep going way up the table, it will get steeper and steeper and steeper until it almost becomes vertical. No, it never becomes perfectly vertical.
Isn't any line technically vertical?
No. So it'll end up looking vertical.
But that's still curved. That's right.
It's still got a curve. If I zoom in, I can see the curve as soon as I start to get in.
Oh, then is it the opposite?
No, I don't know what you're trying to get to, so let's have that conversation at lunch or something. So, try these tables. What you're looking for is... Actually, so what we want... I'd like you to write this here, if you would. We want y to be equal to some value, and actually I'm just going to put an empty line, times the x. You want your y to be some multiplication of x, but it needs to be a number. It cannot be like x squared, because that will change the multiplication every single time. So, and what number would go on this line? So, if there's a relationship from x to y, figure out what it is. It is in and out tables. It's your input and your output. X is your input, y is your output. When we get to functions, we will do a lot more with this. I'll do my first two and then we'll shift the page. For warning, Jeremiah Hone? Okay, making sure. I need to put the phonetic pronunciation on there. Jeremiah, Flynn, Solomon, and Andrew, you are the next four on The Price is Right. So you will be called on for the third table here to determine if it's a proportional relationship. So if you need to talk to your neighbors right now to figure this out, do so. So Jeremiah, Flynn, Solomon, Andrew. Take a minute. You can talk amongst yourselves if you want. Check with each other. Argue if you need to. What's that?
Can it also be like y equals x divided by
It wouldn't be so we really would actually think about it as multiplication by a fraction. So what fraction could I multiply by to go from x to y? A half. Because division is technically multiplication. So we don't want to really talk about division if I can keep it as multiplication.
So if it's like, if it should be division, just use the fraction.
Exactly. Because multiplication by a fraction is how we got to division. Division didn't exist before we had multiplication. You can technically go either direction, but we want to look at x to y.
Okay, because it could have either been doubled or divided.
Exactly. So, a couple of people have now asked, could this be a fraction? Because we don't really want to make this division. If we can avoid division, we always avoid division if possible. So, I could put a fraction here. I could have like 1/2 or 1/3 or 1/4. I can insert a fraction multiplication to essentially do division. So, Jeremiah, on the first table there that I have red on, is there a direct multiplication to go from x to y?
It's not proportional. The only way you'd ever be able to do that is by squaring it. Squaring x by itself.
So squaring 3 squared is 3 times 3. That is not 9.
No, sorry. It is proportional. You multiply by 2, not squaring it.
So yes, here y is 2x. It's 2 times the x value. So if you want to get a jump start on our lesson 2 days from now, go ahead and start writing these equations so you're used to it. In the second one, Flynn, could you find a relationship between your x and your y there? What is it?
2.
If I go this way, it's 2. So if I go this way, what would I actually multiply by? What's the reciprocal of 2? That's additive inverse. So, to go from y to x, I agree. We could do times 2. But if I go from x to y, how can I multiply and go from 8 to 4? You can phone a friend.
You can multiply 8 by half.
Yeah, so think about it like this. If this way is 2 over 1, then this way is the reciprocal of 1 over 2. So yes, here y is half of x. So please write that formula. Y is half of x. On my third table here, Solomon, when I'm going from x to y, I have 3 to 9, then I have 12 to 36, I have 4/9 to 4/3, 1 1/3 to 4. What relationship do you think there might be there? Or do you think it's proportional?
Yes.
Yes? What's the relationship?
Multiple of 3.
Multiplication of 3, so let's check it. Times 3 works, times 3 works, times 3, do it as a fraction. That would become 12 over 9, which reduces to 4/3. That works. If I did 4/3 here, because that's technically 4/3 if I write it improper, times 3 would give me 4. This works out. Y is 3 times the x. Good work, Solomon. And Andrew. Bring us home. What do you think on the fourth one?
Not proportional.
Why is it not?
Because already from like third or second one, we already know that 8 times a half would be 4.
Yeah, so this would have to be times a half.
But 7 times a half would be 3 and a half. But
Yeah, it'd
it's
be
just
awkward.
3, so it's, and then 3 and a half. It's for 2. It's not even. It's for 3.
Yeah, that's a third. This would be a fifth. So guys, if you really want to understand this, I would off to the side here make a note that this was a half. This was actually 3/7 is what you would multiply by there. It'd be really awkward. And that is a repeating decimal forever. This would be 1/3, and this would be 1/5. So absolutely no, it is not proportional because it is not a consistent multiplication. Monica?
It's not a proportion, but if you want to write it as an equation, it's y equals x minus 4.
Yeah, but that's not proportional. So, I can agree with this, and we can write this equation, because, I mean, I like that you made that identification. It's just dangerous because you need to identify this is not proportional. But if I want to represent how I could get y from x, subtract 4, subtract 4, subtract 4, subtract 4. So my equation becomes y equals x minus 4. Go ahead and write this down, guys. But the issue is that I have something added or subtracted that makes it not proportional. That is exactly why it's not. If it was just y equals x and there was no minus 4, that would be proportional. Like, what if I asked you, what if we had hat day? Every single person wore a hat to school. What if, we normally don't do that because it quite frankly, people can bring lice and things easier that way. And the hat thing goes to safety with big schools. They don't want people covering their face to be able to see them. But if we had hat day, how many hats would there be if there were 20 people in the room? 20 hats. How many hats would there be if there were 0 people in the room?
0.
So, how many hats would there be if there were 4,200 people in the room?
4,200.
So that situation would be represented by the number of hats equals the number of people. And that, hey, hold up. Is this a multiplication?
Yes.
By what? By 1. So even when they're directly equal, it's
What if people
proportional.
wore 2 hats?
You can't. You're only allowed 1 hat. Sorry, you can't.
Technically, what if someone wears a hat in a room? Yeah.
That's what I was thinking in my head.
What
What if you have a
already
toupee?
asked what if everyone had a hat?
What if everybody asked what if questions on every question in class? Try this table.
I'm pretty sure most people are.
Now here's a nice easy trick that I think a couple of you have identified. If I can relate my starting x to y in some nice fashion, then I can then just check, does this work in every other situation? You can talk amongst yourselves if you need about the math. Good question. What do you think? If on one step I go from x to y through multiplication of 5, and on the next step I go from x to y by division of 5, is that doing the same thing?
It would
If you
work
wanted to
if
turn
it
it
was
into addition, it would be multiplication of 5 and then multiplication of a fifth.
So, Julian, have you and Solomon figured out what I could write here to relate my y to my x? What did I do to my x to get to y?
Multiply 1/5.
Multiply by 1/5. Now, really, that was Julian's question, so I'm going to go back to Julian again. In the next one, 3 to 15, how do I go from my, like how do I get my y from my x?
Times 5.
So that was 5 times the x. So if this was the x times a fifth, and this was the x times a 5, are these the same? No. So these are not the same. Therefore, this is not proportional. I was debating writing some fancy something or other, but we don't need to. And actually, you can start abbreviating proportional prop if you want, because we really don't use many other words that use that. So you can just say not, P-R-O-P. Make sure that you understand how to spell it, though. It's proportional. Like, kind of like national or those sort of, any word that ends in the I-O-N-A-L. They're kind of all the same. Yes. What? Sure, if I had any, I'd give you one.
Really?
So when you pay for each item at a copy center, the price stays the same. But when, so look for the table of copies, determine if this is a proportional relationship. So sometimes places start to give you discounts when you order certain amounts of things. Now, if we make our cost, if we want to write a statement that our cost will equal something times the number of copies. Let's be analytical for a second. We've done a little bit of this whole equation, how do I get something by itself sort of thing. If I wanted to get this question mark, my unknown, oh come on. If I wanted to get my unknown value by itself, what could I do? Andrew? Somebody said it. Manasa?
Divide by copies.
I want to get rid of copies, so I could just divide by copies. So essentially, to figure out how I get my cost from my number of copies, I'm looking for this, right? But I know it's not going to be a multiplication by an integer because my value gets smaller. So instead of like guessing through this, to find a multiplication, do the division of the reverse. If you want to multiply going this way, and if you have a calculator right now, this would be beneficial, just do the division reverse, because division this direction is the same as multiplication the other direction. So if I do the cost of 18 divided by the number of copies of 150, what do we get, Noah? 8.3.
Oh, it's the other way.
Yeah, we want cost per copy is essentially what we're figuring out right now.
0.12.
Yeah, 0.12. So that would be 12 cents per copy, right? So we can figure out now this multiplication is by 1200ths. To go, now wait, we need to check, does that keep working? So what's 225 times 1200ths? It better be 27 or this doesn't work.
It is.
What's 550 times 1200ths?
10. Put 10.
So you did 55 divided by 550?
Yeah.
Yeah, you're checking these other divisions?
Yeah.
So this comes out to be 0.10. So is this table proportional?
No.
No. What just happened to my price?
It went down.
It went down. Now wait, what about 84 divided by 1050?
That's
0.08. So what statement could we make? We know this is not proportional.
Definitely not. It's cheaper than 45.
Ah, the price goes down as quantity goes up. Price goes down as quantity, which you can abbreviate QTY, goes up. 2.1 is already posted alive on Schoology, so is 2.2 if you want to give it a shot. We will pick it up here. We should be pretty quick at finishing up this lesson tomorrow. and then dive into proportional relationships in graphs. What? I agree. Chapter 2 goes pretty quick. Tomorrow we may actually cover 2 lessons at the same time. Oh, thanks. I never really care much about these. You give it to me, but really it just goes in the trash. All that really would matter is if somebody, like, you were on your way and somebody was like, where were you coming from? Or something like that.
I have a riddle for you. Yeah, I like